All right, folks, this is lesson 5, permutations with repetition. So all the examples we've used so far, the words that we've used have individual letters. None of the letters are the same. So let's figure out, let's examine this first situation of the word rose. So we're going to do all the different permutations of the word rose. And here they are. So 4 factorial ways to arrange it. There's 24 different versions of the word rose. Okay, there's the ones with the R, starting with R, and then starting with O, starting with S, and starting with E. Okay, and they're all unique. There's nothing that's the same. If we change the E in the word rose to an S, we get the word Ross. So we are repeating the S. And here's all the different arrangements of the word Ross. Okay, if you could kind of think about, this first one here, this could be your first S and your second S, and then you could swap those tiles, right? So we have the same Scrabble tiles, we're just kind of like flip-flopping their order. However, if you look, we still have the same word, right? It still says Ross. Even though we've swapped the words, it's still the word Ross. And that happens a bunch of times. RSSO, ORSS, okay, OSRR, there we go. And then see how that one repeats with that, and that one repeats with that, and that one repeats with that one, and it just keeps going, okay? We have a whole bunch of repeats, and it's because the letters are the same. So even though we're kind of swapping these Scrabble tiles, we still get the same word, okay? So let's cross out the ones that are double. So that's a replication, that's a replication. RSSO is a replication. Oops. RSOS is a replication. ORSS is a replication. OSRS is a replication. OSSR is a replication. SROS is, SRSO, SSOR, SSRO, and SORS. So how many do we have left here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think I missed one. SSRS. Oh, that's a replication too. Okay, so we have 12. So let's do 4 factorial, and we're going to divide it by 2 factorial, the ways that the S's can be arranged, okay? And we end up at 12. So the S repeats. If a letter repeats twice in a word, we divide it by 2 factorial. And this leads us to our general situation here, where the number of permutations of n objects, so in this Ross or Rose example, we've got 4, where A are the same of one type, B are the same of one type, and C are the same of yet another type. Now in our example, we only used the first part of it, okay? If there's more repetitions, you simply divide by those repetitions. So here's Vancouver. Let's do this bad boy. So any letters that repeat. So the V repeats. Anything else? There's no other A, there's no other N, C, O, U, E, and R. So there is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 factorial ways in total, and we're going to divide that by 2 factorial, which is the V repeat. And we end up with 181,440. Mathematical. All right, so we've got the M's repeating twice, so 2 M's. We've got 2 3 A's. We've got 2 T's. Anything else? H, no. E, no. I, C, and L. Okay. So in total there's 12 letters, so 12 factorial, and we're going to divide that by 2 factorial for the M's, 3 factorial for the A's, and 2 factorial for the T's. And we end up with 19,958,400. All right. The word poppies. So we have 3 P's. Anything else? Nope. So there's 7 letters in total, and we're going to divide it by the 3 repetitions, so 840. What if each arrangement begins with the letter P? Interesting. Each arrangement begins with the letter P. So how many arrangements do we have? We've got 1, 2, 3, 4, 5, 6, 7. And we've got 3 P's, so 3 options. And then we're going to go 6, 5, 4, 3, 2, and then 1. And that gives us 2,160. But divide that by the P repeats. Okay. And we get 21. Oops. Do not get 21. We get 360 arrangements. If the first 2 letters are P, okay, so we still have a 7-letter word. And we need to be, the first 2 are P's, so we have 3 to choose from, and then we have 2 to choose from, and then 5, 4, 3, 2, 1. Okay, so that gives us 720. But again, we're going to divide by the repeats to get 120. Okay, because even though we pick one of the Scrabble tiles that has P, if we swap it out with another Scrabble tile that has P, it's still the same arrangements. If all the P's need to be together, so like that, and then we've got O, I, E, and S. So 5 factorial, 3 factorial, divided by 3 factorial gives us 120. Okay, the 5 factorial is the 1, 2, 3, 4, 5, so the number of ways that we could swap those tiles around. And then the 3 factorial is the way that we could arrange those P's on a single tile. But we're going to divide by the 3 factorial because it doesn't matter. It's still the same arrangement, right? Whether you have, your first, your second, and your third one, or your third, your second, or your first one, it still says P, P, and a third one, okay? If the first letter is P and this next one is not P, so we have not the letter P. So we've got 3 choices. And then how many choices do we have that are not that letter? Well, there's 4. And then no restrictions for the next 4, 5. So then we go 5, 4, 3, 2, 1. And we get 1440. But hold on, we need to take that and divide by the repetitions, and that gives us 240. All right. Home builder has 3 models of homes. They can choose A, B, or C. On one side of a street, the builder sold 3 Model A's, 4 Model B's, and 2 Model C's. How many ways can the homes be arranged along the street? So what do we actually have? We've got A, we've got B, 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 and B, and then we've got C and C. So in total, there's 9 homes. So, if you think about this as like the families that are moving in, there's 9 families, so you could swap them all out. But the homes are the same, so we're going to go 3 factorial, 4 factorial, 2 factorial. So there's 1,260 different arrangements of the houses. Brett bought a carton containing 10 mini boxes of cereals, 3 cornflakes, 2 Rice Krispies, Cocoa Pops, Shreddies, Raisin Bran. So how many Raisin Bran are there? There's got to be 3. Okay. How many different orders are possible if on the first day he has Raisin Bran? Okay. So let's just go over what we have. We've got CCC, RR, Cocoa Pops, so P for Pops. S for shreddies, and then 3 boxes of bran. So if he's got 10 days to deal with here, 4, 5, 6, 7, 8, 9, 10, and on the first day he needs to have bran, there's 3 boxes for him, right? So he can pick one of those 3. And then it doesn't matter what he does on the other days, so 9, 8, 7, 6, 5, 4, 3, 2, and 1. So he's got 1,088,640. However, you need to take that number and divide by the repeats. So 3 repeats, 2 repeats. You don't have to put the 1 for the Cocoa Pops or Shreddies because it doesn't matter. And then 3 factorial. So if we simplify this, our options are reduced quite a bit. But still, a ton of different ways that he could consume cereal. Must be a hungry guy. Okay, sometimes you're going to get these pathway questions, which are, city block type situation. So a city center has a rectangular road system with 5 cars, 5 streets running north to south, and 6 avenues running east to west. Old Shawnee boy is driving a car, and he's at the northwest corner, and he wants to get to this corner. Okay, so, he could go straight that way, he could go, that way, he could go that way, he could go that way, he could go that way, that way, that way, that way. Okay, so he's got a ton of different ways. So I do not recommend doing what I just did. Let's simply figure out how many ways can he go east. Okay, so he's got 4 east blocks to go, and he's got 5 south blocks to go. So he's got 9 blocks to travel. So the number of ways to do that is 9 factorial. Okay. However, the east, if he goes 1 block east here, it's the same as going 1 block east here. It's the same as going 1 block east, 1 block east. So we have these repetitions. Okay. So we're going to divide by the 4 factorial for east and the 5 factorial for south, and we're going to end up with 126 different ways. Find the number of pathways if you're going from A to B, if they must always move closer to B. So that means you're not going to go here, there, and then back. Okay, that's farther away, so you're not going to go back. So we're simply going 3 to the right, 2 down, and see how A is in like the back and B is in the front? That might be a little tricky to see actually. We need to go 1 front. Okay, so we have right, 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 down and down, and front 1. So in total, there's 6 moves to make, so 6 factorial, and then 3 factorial, 2 factorial for the right and the down, and we get 60 different ways. Okay, now you could highlight this if you wanted. This is your total moves, and this is the repeating rights, and this is the repeat down. Okay. And that's the end of lesson 5. Good luck in the homework.